Hello guys, in this section we are going to do motor driver inside Proteus. So open a new project. So go to File, New Project. Create a name that you like. So agent_project. Click Next, 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 and Finish. So it will open a window like this. And we have to pick components from pick a library. So click P, and we have learned that L293D is our motor driver. So search for L293D. Just type L293D. So we have got L293D. You can see the schematic over here. Just double click on that. So double clicking that thing, the component will appear over here. Next thing we want is that an Arduino, because through Arduino we are actually giving the inputs to the input 1, input 2, input 3, input 4 of L293D. So just search for Arduino. So choose Arduino Uno. You can see the schematic over here. Okay, then one more we need is DC motor. So just type motor, MOTOR. Choose motor DC. Just look at the schematic and choose it. Click OK. So we have all our components. Then place the L293D here. Just click over there and click again here. So it will be placed. Just so I'm zooming in. You can see the L293D over here. So this is similar to that of the IC that we see in the lectures. So for your time being, I opened that. So this is the IC that we learned, and it has 16 pins, enable 1 and enable 2 input pins as well as output pins along also ground. So here also same thing: input 1, input 2, input 3, input 4, enable 1, enable 2, output 1, output 2, output 3, output 4, and we have only 1 ground instead of 4, and we have VSS as well as VS. So it is same as that of a real L293D, or what you see in real. So this is another advantage of a Proteus, that things what you see in real world is similar to that of what you see inside the Proteus also, because the components are almost similar. Next is we can place the Arduino. You can change the orientation over here. So my orientation, I'm keeping that like this. So I place here. Just we don't need this much. So okay. You can double click and again drag over other place that required. So next, place the DC. So check that you have to place your DC motor in this fashion. So like that only it will rotate according to your the input you are giving, because if you place in the other way, it might rotate off anti-clockwise instead of rotating clockwise. Now connect the DC motors. So from output 1, connect the one end of the DC motor, and from output 2, connect the other end of the DC motor. Similarly, the other DC motor is connected from output 3 as well as output 4. Okay. For getting the wire, just double tap, you will get the wire, and drag and again click tap. So by again tapping on the touch screen, you will the kind of wire will get connected like that. Then now we are connecting Arduino as well as the L293D. So connect the second pin of Arduino with the input 1. Then third pin with the input 2. Then the fourth pin with the input 3. Sorry, if anything wrong happen, just click escape, so the wire will get deleted. Then fifth pin, I'm connecting input 4. Okay, Next is connecting of the connection of the enable 1 as well as enable 2. Connect 11th pin with the enable 1 and 10th pin with the enable 2. Now we have to provide the voltage for the running of this motor as well as for the running of this IC. So let's look at the slide again. So VSS is provided with 5 volts. So this VSS is the part where you are providing the voltage for running of this L293D, and VS is the part where you are providing the voltage for running your motor. So let's move. So connect the VSS with 5 volt. So we can take the 5 volt from Arduino itself. So Arduino can give a 5 volt from the pin that over here. So just drag wires, put VS with 5 volt. Now VS, only VS. Now you should connect the VS with 12 volt battery. I can do it in two ways, either by taking a battery of 12 volt and connecting our VS as well as ground, the VS with positive and the ground with negative, or the other ways that I will be describing here. So go to terminal mode, you can see here, and pick power and check the orientation. This orientation is perfect for me. Just place it here. Sorry, just drag that thing. Okay, no, it's correct. Then double click that thing and type plus 12 volt. So this has same effect of that of a 12 volt battery. Okay, now connect the ground with ground. For getting the ground, go to again terminal mode, pick ground and tap here again, tap here. Okay, now ground got connected. Now we have our every connections are made. So in order to adjust your views, you can actually double click and drag, and when you think your view is correct, then again click over there, so it will be positioned correctly. So this is the entire view of our circuit what we made. I hope you all understood. Now we have to write the code for running of this motor in all conditions, forward, backward, right, left. So, and we have to paste the hex file in this location. For doing that, we have to write the code inside the Arduino IDE. So everyone, please open Arduino IDE. I have already made the code for motor drivers. So I will explain each and everything by line. So we have used the pins 2, 3, 4, 5, and 11 and 10th pin of Arduino. So they should be initialized. So this is the initialization part. I am naming int 1 with the pin number 2, int 2 pin number 3, int 3 with pin number 4, int 4 with pin number 5, and enable 1 is connected with 11th pin, enable 2 is connected with 10th pin. And this is a declaration of a character C with a character data type, and I will say what is its use in the coming lines. Next, we have void setup. Void setup is place where we are running the code for only one time. So here we are mentioning the pin modes. That's whether the pins that you are declared above are inputs or outputs. So input 1, input 2, input 3, input 4, enable 1 as well as enable 2. These all are outputs from the Arduino. As you can see in the Proteus, since these pins are outputs from the Arduino. Through this, you are providing signals to the L293D. So those all are outputs. That's why we are naming output inside the pin mode. So that is the only thing inside the setup, void setup. Next thing is the void loop. Void loop means something that will run continuously, like that of a loop. So inside the void loop, I have mentioned the enable 1 and enable 2. And you can see in the Proteus, I have connected the enable 1 as well as enable 2 with pin number 10 as well as pin number 11. So these are PWM pins. The use of PWM pins in the Arduino is that you can able to control the voltage that required to provide through the output through these pins. So by controlling the voltage of the enable pin as well as enable 2, you can actually control the speed of the motor in which they are rotating. If you connect the enable 1 and enable 2 with other pins that is not that are not PWM pins, they will the motor will rotate, but they will only rotate with that maximum speed. So in order to control the speed, you have to connect it with any of the PWM pins. So I have chosen 10 and 11. You can choose 9. 5 we have already connected. So it will act as either digital pin or enable pin in case of input 4. And it will depends on whether it will act as a PWM pin or a normal pin depending on the code what you are writing. So in order to use the enable pins, you have to mention the value ranging from 0 to 255, because 0 is a low voltage, 255 is the maximum voltage. So you can able to control the voltage in between these ranges. So unlock write enable 1 comma I just mentioned I can mention some value between 0 to 255 by 100. So it will rotate with much less speed compared to the full voltage. So both pins I am mentioning enable 1 as enable 2 will has its voltage value corresponding to that of 100. So I will come to this. So now we have to say the condition for forward, backward, left, right, and stop. For moving the forward, we have to put the input 1 with high and input 2 with low, input 3 with high and input 4 with low, as I discussed in the slides. That is, in order to move forward, the condition for forward is input 1 with high, input 2 with low, input 3 with high, and input 4 with low. So thus the two motor will rotate in clockwise direction and will lead the motor to move forward. Similarly, backward condition is the just opposite of the forward, that is input 1 with low, input 2 with high, input 3 with low, and input 4 with high. In order to move towards the left, input 1 is kept at low, input 2 is kept at low, and input 3 is kept at high, and input 4 is at low. That means I am keeping the left part at rest position and moving the right part. So in order to move towards the right, I have to keep the right part as rest and move the left part. That's why input 1 is in the forward condition. That is, input 1 is high and input 2 is low. So this is in the forward condition and the other two at rest. In order to stop, I have to mention all pins as input 1, input 2, input 3 are 4 as, and 3 and 4 as also low pins. So these all are low. So here the value of C. So depending on the value of C what you are mentioning, so it is just a hard coding, but in order for the demonstration it will be fine. So when I mention C is equal to 1, here I can able to edit the values. The motor will rotate in the forward, both the condition will be in forward condition. So you can change the value here and you can see how it moves backward, left, right, and stop. So let's verify our code and paste the hex file. So before verification, you have to check that in the preference in the file, then go to preference whether this compilation is ticked or not. So just tick the compilation, so that will generate the hex file. So just after that, then verify your code. So verification is done. You have to search for .ino.hex file. So, and copy that path. It's a path. Copy that path except the double invert commas. So Control plus C. Then come to the Proteus. Double click the Arduino. Then paste here inside the program files. Click OK. Since I mentioned C is equal to 1 here, so we are expecting the motors will be in forward direction. So run the simulation. You can see that both motors are moving in forward direction. Okay. For your understanding, I am naming here it as left tire as well as this as right tire. So go to 2D graphics text mode. Then just tap here. So it will open a box like this. Then type left. You can adjust the height over here. Then you can change the font and click OK. So it appeared. And just right clicking to drag this object because since it is not at the correct position. Okay, now it is correct. So this got named left. So this part, how to give it as right. So again, so since we are already at the 2D graphics mode, again click tap here. Okay, I'm tapping here. Click right. Type right. And click OK. Okay. And just right click to drag this object. So drag object, then place it here. Or place it here. Okay. Really fine. Okay. So now we have named the left as well as right tires. Now we can check we can control the speed by just adjusting the values inside this analog right for the enable 1 as enable 2. So I am giving, instead of 100, I am giving it as 10 for both the tires. So once you have already verified your code and uploaded the path file, that is .ino.x file in the Proteus, you after this point onwards, you never need to copy the path again and you can paste on the Proteus. You don't need to do that. You need to only verify this after you make your code. After you made any addition, you just need to verify here. Then directly go to Proteus, again run the simulation. No need to upload the code again. No need to copy the path again and paste in the Proteus. So you can see now the motors are rotating with a less speed compared to the initial case. So that is the use of PWM pins in case of Arduino. Now we can check one more condition, that is right. So in order to move right, I have to mention C is equal to 4. So provide C is equal to 4. I have make the change and I'm just verifying the code. So my verification is done. And coming to the Proteus again run the simulations. So you can see this motor is at rest and this motor is at moving. So that means that it is a condition for right. So the right part is at rest and left part is already moving. So this is a condition for right. Similarly, you can do the left condition, stop condition, everything. And you can adjust the speed of the motor like that. I hope you understood about motor drivers. Then if there any doubt, you can contact us anytime through email or WhatsApp. So thank you guys.